Hey Chem Kids, Campbell here. In video 1 in chapter 19, we're going to talk about oxidation reduction reactions. Grrr. So what is an oxidation reduction reaction? Well, it's one that involves the transfer of electrons between elements or compounds in a reaction. So if electrons are being transferred, that means somebody's gaining electrons. And if they're gaining electrons, we call that reduction. Well, that seems weird, right? If I gain something, I'm being reduced. But remember, electrons have a negative charge, and so if you look at this example, you can see why they call it reduction. Here's copper plus 2. It gains an electron and becomes copper plus 1, so that charge was reduced because electrons are negative. And in fact, if we write one of these little half reactions, we can see that the electron is on the left side of the equation because I'm gaining it. So it's a reactant. We actually also have another name for the thing that is being reduced. We call it the oxidizing agent because it's the agent that causes the other one to be oxidized. Because if I'm reduced, I'm gaining, and I got to get them from somewhere. So oxidizing agents are the thing being reduced. So what's oxidation? Well, that's the opposite. So some atoms have to lose electrons, right? You can't gain them unless they're coming from somewhere. So the ones that are the losers of electrons undergo what's called oxidation. And so you can see here that if I lose electrons, I'm losing negative charge, so my charge is actually getting bigger. Here I went from potassium without a charge to potassium plus 1 plus an electron. And notice that the electron is on the right side of the equation because I'm losing it in the reaction. So gain electrons, reduction. Lose electrons, oxidation, and of course, we've got another agent here. This is also something that undergoes oxidation is called the reducing agent. It is the agent of change, so it is causing reduction in the other thing. So it's called the reducing agent, but it's the thing being oxidized, so don't mix those two things up. Now, oxidation reduction reactions, you will see me abbreviate them as redox reactions because it's easier to write redox than oxidation reduction reaction. They occur together, right? In order for something to lose, there has to be something to be gained. So the number of electrons that are gained by that thing being reduced have to be equal to the number that were lost by the things that was oxidized. So the number of electrons have to be equal. They can't just go off into space. Now, you need to be able to recognize what is oxidized and what is reduced. So we have a couple little things here to help you remember them. One is oil rig, and I will tell you, I don't really use this one, but some people like it. Oil rig stands for oxidation is loss, right? It's the loss of electrons. And reduction is gain, or the gaining of electrons, so oil rig. Now, when I was in high school and in college, I used Leo Grr. So when I lose electrons, I'm oxidized, and when I gain electrons, I'm reduced. So if you ever ask me a question in class, is this oxidized or reduced, you'll hear me saying lose electrons, oxidized, or gain electrons, reduced. So that's one I use, but you choose, whichever works best for you, or make your own. So the next thing you're going to have to be able to do is figure out who's being oxidized and who's being reduced in a chemical reaction. So what you want to do is you want to look at the charge of the atom when it's in the reactants and then find it in the products and see how that charge has changed. So you're looking before the arrow, right, that's the reactants, and after the arrow is the products. So remember, though, that electrons are negative. And so when I lose electrons, right, Leo, lose electrons, oxidized, it means that my charge is becoming more positive, less negative. And if I'm being reduced, right, that means I'm gaining electrons, gain electrons, reduced, and that means my charge is becoming more negative or less positive. So let's take a look at an example. Here we have lead plus 4 plus copper without a charge, yielding lead plus 2 plus copper plus 2. Which one is being oxidized and which one is being reduced? Well, let's split them into half reactions. So let's pull the lead out, and let's pull the lead out, let's pull the copper out, and take a look at how those charges are changing. So for lead, we're going from plus 4 to plus 2. So notice we got less positive. All right, less positive means that we are gaining electrons. So gaining electrons, means that the lead plus 4 is undergoing reduction. For copper, we have the copper without a charge going to the copper plus 2 ion. And so here we have a charge that's becoming more positive, right? We went from 0 to plus 2. So if I'm becoming more positive, that means I'm losing electrons. And if I lose electrons, Leo, lose electrons, oxidized. So look at how the charge changes as I go from the reactants to the products. Am I getting more or less positive? More positive means I'm losing electrons, oxidation. Gaining electrons, I'm becoming less positive or more negative, and that means it's a reduction. All right, how about you try this one? We have aluminum plus iodine yielding aluminum plus 3 ion and iodine minus 1 ion. Who's being oxidized and who's being reduced? All right, well, let's see. Did you get them right? Aluminum is going from a neutral atom, so a charge of 0, to plus 3. So that means I'm becoming more positive. If I'm becoming more positive, that means I'm losing electrons. Leo, lose electrons, oxidized. So the aluminum is becoming oxidized. That means that iodine has to be reduced, because if something's being oxidized, somebody's got to be reduced. But let's check. So iodine also starts out as a neutral, and it has a neutral charge, so a charge of 0. It's becoming a charge of minus 1. So it must be gaining electrons because it's becoming more negative or less positive. And if we gain electrons, we're reduced. Grr. So if you said aluminum is being oxidized and the iodine is being reduced, you are correct. How'd you do? We'll do some more of this in class, so I will see you in class.